So to simplify these radicals, the first thing we need to do is to think of square numbers, perfect square numbers. Now, perfect square numbers are those numbers that come from multiplying the same numbers by themselves. Yeah. So, for example, for 16, the square root of 16 is 4, because 4 times 4, 4 times 4 is 16. So with this one, in this first part A, the answer is directly 4. So this is equal to 4. And that's it. When it comes to 18, we have to write this 18 as a product of at least one perfect square number multiplied by another number. So here, if we can think of numbers, 18 itself is 18 can be written as 1 times 18, or it could be written as 2 times 9, or it could be written as 3 times 6. That. Now, choose the pattern here. I mean the pair that has perfect square is actually this one, which has 2 times 9, and that is the one that we want. So we're going to write 18 under root 18 as under root 2 times 9. This is the same thing as we can find the square root of 9, but we cannot find complete square root of 2, because square root of 2 won't be a complete number. It will be a number with decimals. It won't be a whole number, and we want a square root of a whole number. So square root of 9 is 3. We write 3 there, but the 2, to avoid the decimals, we are just going to write the 2 with the root itself. So we're going to write the 2 as square root of 2. That's it. That is the simple way of writing 18 under root 18. When it comes to 20, also we're going to do the same thing. We're trying to write 20 as a product of at least one perfect square number with the other number, and this is 20. 20 can be written as 1 times 20, or it could be written as as 2 times 10, or it could be written as 4 times 5. And the only number here, the only pair that has a perfect number is this one, and this is the one that we are taking and writing that 20 as. So this is going to be square root of 4 times 5. That's that. And to find the square root of 4, that's easy to get. Square root of 4 is 2, but square root of 5 cannot be a whole number. So what we write there is square root of 5, we're going to leave it as it is, but the square root of 4, it can be found, and that is going to be 2, and the other one is being left as it is. So this is 2 square root of 5, and this is the final answer. So simplification of square root of 20 is just 2 square root of 5. 128. 128 can be written as 1 times 128, or it could be written as 2 times 64, and so on. So since we already found our perfect number here, perfect square number here in 64, because 8 times 8 is 64, so we're going to write this 128 in that form. Instead of writing 128, we're going to write that as square root of 64 times 2. And square root of 64 is 8, but square root of 2 is a decimal number. We're going to leave that as it is. We don't want decimals, we want whole numbers. This is going to be 8 times square root of 2. So square root of 2 will remain as it is, but square root of 64 is 8, so we write 8 instead of 64 under root. And this is it. So simplifying 128, the answer is just 8 square root of 2. That's that. And we have 27, part E. Again, 27 can be written as 1 times 27. It doesn't have a 2 here, so we can go to 3. 3 times 9. And we see this is already a perfect number, a pair with a perfect square number, which is 9. We know square root of 9 is 3, so we're going to use this pair instead of going further. So this is going to be, instead of 28, instead of 27, we're going to write that as square root of 9 times 3. We can find square root of 9, which is 3, but we cannot find the square root of 3 without getting a decimal number. So we're going to leave that as it is. So to simplify, square root of 27, that is just going to be equal to 3 square root of 3. And that's that.